Okay, so let's go to our hard card on the milling machine and let's go through the milling machine setup procedures. I'm going to start with number one, which is wipe all the ways clean. And on this particular machine and all of our mills, we actually have way covers. So we don't have to do this too extensively, but we can kind of lift this up and see if there's a little bit of chips on the inside of the ways here. And actually on this one I need to go a little deeper because we haven't done that on this machine in a while. So I'm going to do that a little more extensively. But you probably won't necessarily need to do that on this machine. But if there is chips back there, let's get those cleaned off. The same thing with the back weight cover. I'm going to go look and see, and actually this one, it's really clean, so I'm not even going to put my rag back there. I'm going to check the oil level in the one-shot oiler down below the knee here on the left side of the machine. There's a small box with a lever, and I checked these at the beginning of the semester, so they're always full of oil, but it has a little window to indicate if it gets low on oil. And this one, of course, is full. So what you do is you pull this lever down slowly and gently, evenly, all the way until it bottoms out, and then release. And that's number three, activating the oil pump. I'm going to check to see that the tool head is set to 0. We do check the tram of the head, which means that the spindle center line is perpendicular to the table this direction and this direction. Okay? But it does have two dials here with a little indicator mark, and you can look and see each before each lab time on the mill that these are set to 0. We always check these at the beginning of the semester as well and make sure they're tight. I've already checked all the machines, so I'm certain that's good. You can also eventually check to see that the vise is indicated. I do that again on all the vices. I'm going to have a separate informational video on that because it's actually Haas did a really good one that shows that done on the CNC machine, and it definitely would apply on these machines as well. So I have that posted just as informational. Then part of that video will be on the final test. Okay. So I know that the vise is indicated that if I put an indicator and travel along this axis, that the indicator would read 0 from here to here, and the vise is not crooked or slanted, that it is parallel to this axis of travel. Okay? So the number 7 would be securing the workpiece, and in this case, we're always going to want to make sure that our workpiece, where it locates, is always clean. I've already brushed this out with the brush, and you can actually also, with the brush, make sure there's no chips. Wipe this out with a rag, and then go through with your hand and make sure there's no chips. I'm going to also make sure that my parallels here, I have a set of parallels that are the same distance, are the same height. They're thin. I'm going to put them here for this setup, and I'm going to hold this workpiece a little bit higher so it's not too far down in the bed of the vise. So this would be how I would secure the workpiece. I would go ahead and use my vise handle and put my weight on this. I don't want to ever see anyone use a hammer and hit the vise handle, and that's too much force. If your setup is such that you need to use a hammer on the handle vise, there's something else wrong and you need to consider a different way to hold your workpiece. I'm just going to put my weight on it, and that's more than enough. When I remove it, again, I'm going to actually use the fat part of my hand, kind of hold this and just kind of push like this, and that will release it. But again, your weight in this direction going down is plenty to secure this workpiece in a mill vise. So from here, that is securing the workpiece. The one thing though, I would also use a dead blow hammer. I have a dead blow hammer here, and I would move it out of the way, and I would hit this with at least one heavy blow to make sure that the bottom of my part is sitting on the top of the parallels, which are parallel to the bottom of the parallel, which is parallel to the bottom bed of the vise, which is parallel to the bottom of the vise, which is parallel to the top of the table, which is perpendicular to the spindle center line in this direction and this direction. So I get a good square cut. Okay, so that is securing the workpiece. Now I would choose a cutter depending on if this is aluminum, I'm going to use a 2-flute cutter. If it's cold rolled steel, I'm going to use a 4-flute cutter. Depending on how big a cut I'm going to take, how much flute length I need, I'm going to make sure when I select the cutter, I'm going to also select the arbor as the next step, and I'm going to make sure that when I select the arbor, I have 2 arbors here. I've got a 1/2 inch diameter end mill holder, and I've got a 3/8 diameter end mill holder. The shank of this end mill, this is a 2-flute end mill. You can see there's 2 flutes on there. The shank of this end mill is 3/8, so this would fit in there perfectly. And you can kind of see it doesn't, it fits in there snug, and I can kind of pull it out a little bit. Yeah, I would not use the 1/2 inch end mill holder for this because it does not fit snugly within the, now this is a smaller diameter, so you could physically get it in there, but the cutter would not be rotating concentric and it would not be held in this safely. So you've got to make sure you use the correct size. And then once I have the correct size selected, I'm going to make sure that this set screw is sitting on there's a little cutout of the shank of this end mill here. And this is called a Weldon shank. And this set screw needs to sit right in and clamp the end mill within the end mill holder. So I'm going to put this back in, and there's a pretty easy way to determine. I can look and see that this is where I'm going to look and see where that Weldon shank is. I'm going to put this down in here all the way. I'm going to bring the set screw down all the way, and if I rotate just a 1/2 of a turn, I can try and pull this out, and I can see that the end mill will not rotate and it can't pull in or out. So I know that I'm on the Weldon shank. So at that point I would then, again, while the end mill holder is installed in the head, in the spindle, then I would, after selecting the correct end mill, selecting the correct holder, I would install the end mill holder, or number 10 is mount the arbor. And this is the arbor, or we call this the end mill. It's a solid end mill holder. I'm going to move the workpiece out of the way, and to install the arbor, I'm going to make sure I'm in low gear. I'm going to bring this end mill holder up. I'm going to screw in the drawbar, and with my box end wrench, I'm going to, in low gear, I'm going to tighten the arbor for the end mill holder. Now I know that this is secure in here, and I can go ahead and install. I'm going to go into low gear so I can rotate the head and see the set screw. And then make sure the set screw is on that Weldon shank. I know it's tight. So that's 11 mounting the cutter. I'm going to determine the correct spindle rotation. It's always going to be clockwise. This is a right-handed end mill. we only use right-handed tools here. So I'm going to go to, oop, it's grinding. I didn't get it in gear all the way, so I'm going to rotate this around and make sure I thought I was in high gear. So if it makes a noise, I'd stop it immediately and then make sure it's in high gear. So now I'll start it again. I know I'm in high gear. When I select forward, it rotates clockwise. If I'm in low gear and I need to push this lever all the way back and pull it out as I bring it all the way to the back, now I'm in low gear, it's very hard to turn. In order to turn clockwise, which I would need to do on all of our tools in low gear because they're all right-handed end mills, I would actually switch to reverse. And now my end mill is rotating clockwise. So I'm going to stop it. I'm going to go back into high gear. So I know I'm forward for high gear. I would set my spindle RPM now. That's 13, set the spindle speed. And then when you're cutting, what I would do, always I'd like to see everyone bring this stop up. There's a little spring loaded here. You can press these buttons and rotate this quill stop up and down. Bring this about 1.5 inches. Bring your quill down. Bring your quill down with your handle. And this little lock will lock this in place on this stop. So you have a little bit of clearance. I'd like to see this on every time you're milling, especially when you're facing. But you want a little bit of, you don't want this sticking out too far, but you also want a little bit of room, just in case I have an issue and I need to kind of bring this over the top of the part or move this. I can move this out of the way and I know I'm clear of the part. So it's always a good idea to have a little bit of clearance, bring it down and use the quill stop. Okay? So based on, this is the machine setup procedures. I'm ready to go with my cut. Now the last thing is just to determine, okay, my cutter's rotating clockwise. I am going to cut from this side to the other side for my cut because that would be a conventional cut. I wouldn't start on the back side of the part and cut in this direction because that would be climb cutting. And I can tell by looking at it based on the cutter rotation on which side the material is on when I take my cut. All right, so that's the mill setup procedures. I want you to review all the other videos in this module and you'll be expected to come in on the mill if for that week, if you're on the mill, come in and do the setup just like I showed, and then switch to the other video that shows the cut for that particular project, which in this case our first project is going to be the bolt gauge. So we'll do a minimum cleanup, cut just like this with this setup.